let's talk a little bit about stereochemistry. Now, you've all noticed, I'm sure, that, in fact, this alpha carbon is chiral, right, depending on the R group, with the exception of one amino acid. Okay? This R group is chiral, and as a result, we can have two isomers. We could have a D isomer or an L isomer, which is based on an analogy to glyceraldehyde. Or we could have R and S absolute configuration. The first definitions of stereochemistry of D and L had to do with enantiomers that were identified by none other than Louis Pasteur, I believe, dealing with glyceraldehyde. And glyceraldehyde, yes?
Is D and L similar to R and S?
Yes and no. So D and L is older nomenclature that then got revised to R and S. D and L nomenclature had to do with analogies based on glyceraldehyde that looked like this. So this was glyceraldehyde. I'm going to draw this better. CH2OH. Okay, and if we draw truly a stereochemical view of glyceraldehyde, glyceraldehyde looks like this. Glyceraldehyde. Okay, and I can draw a mirror plane. And I can draw the stereoisomer of this, right? So I have two stereoisomers. It turned out that this isomer of glyceraldehyde rotated a plane of polarized light to the left, and so this was called levorotatory, or the L form of glyceraldehyde. This rotated a plane of polarized light to the right, and right, dextro for right in Greek, and so this was dextrorotatory, or D-glyceraldehyde. And then what people did was, based on these configurations of glyceraldehyde, use analogies between glyceraldehyde and amino acids in order to decide whether an amino acid was or was not L or D form. If I look at the amino acids that we find in proteins, real proteins, they look like this, right? And I'm laying it out so that it looks most similar to glyceraldehyde, right? So I'm putting the carboxyl group where the aldehyde group is, I'm putting the R group where the alcohol is, the hydrogen where it belongs, and the amino group where it sits. This is what we really purify from real proteins. Does this look like the D isomer, or does it look like the L isomer? L. And as a result, we call these L-amino acids. And all proteins, really important point, all proteins from all organisms on Earth are built from L-amino acids. Okay? Why don't we live in a world where there are D amino acids? You know, that's like the world of antimatter. I don't know. It's like Star Trek, right? Matter meets antimatter, it all blows up. Maybe there's an alternative universe where every protein's made of D amino acids, but not the universe we live, not the Earth we live on. Here, all proteins are built of L amino acids. Do you think that all L amino acids rotate polarized light to the left? No, of course they don't. Glyceraldehyde does, but there's no correlation between when we call an amino acid an L amino acid and which way it happens to rotate a plane of polarized light. That's a misnomer based on modeling amino acids as though they were glyceraldehyde. Now, what about absolute configuration, which is the question you asked me about R and S? So as you may remember, Kahn, Ingold, and Prelog, great chemists, decided that there was enough of this L and D stuff that didn't make any sense, let's come up with an absolute configuration. So if we put our alpha carbon here, you remember the way you do this is you put your smallest substituent in the back, right? And then you have a steering wheel of the other substituents. You have your R group sitting here. You have your amino group sitting here. You have your carboxyl group sitting here. And then you order the substituents, right, based on the rules of ordering that you should have learned in 512. And for most amino acids, this is 1, this is 2, and this is 3 in the order of preference. And that means that our steering wheel goes this way, right? And this, therefore, is this S or R? Am I S? That's right. So they're S amino acids. There's one exception. I won't tell you what it is because we're asking you that on the problem set. Okay? But most amino acids, except one, are LS amino acids in absolute configuration.